Welcome students for the second unit of the subject Computer Integrated Design and Manufacturing. So in the first unit of the subject Geometric Transformation, we have seen the different geometric transformation like translation, scaling, mirror, shear, etc. So we have learned how these geometric transformations can alter the size and shape of the object by the modification in the data in the unit number 1. Now in the second unit, that is geometric modeling, we are going to learn the different geometric modeling technique and the various advantages, disadvantages of the geometric modeling techniques. So this geometric modeling constitutes the most important part in the present day software packages. We can see that we use the various software packages in the present day, and the geometric modeling is playing the very important role in all these software packages. So we will see what are the different methods of the geometric modeling and how the geometric modeling will be helpful in the design process in the different software packages. Now, what is modeling? Modeling, we can say, it is the art of abstracting or representing the object, system or phenomena. So we are going to represent our object with the help of this modeling technique here. It may be the system representation also, or it may be the phenomena, that is what you are modeling. So basically we have the two types of modeling. First is your geometric modeling, and in the geometric modeling we can say that in the geometric modeling we have the complete representation of the object with the graphical and non-graphical representation. So we will study the geometric modeling in detail in this unit. This geometric modeling will have the mathematical description of the geometry of the object and the non-geometry of the object. It will be stored in the computer database, and the image of the object will appear on the graphic screen. So whatever modifications we are doing in the image of the object, so these modifications will be done respectively in the computer database. So you can see immediate reflection of the changes on the computer screen, but these changes will be done in the respective database which is stored in the computer, and then we can immediately see the changes what you can see on the computer graphics or on the screen of the computer. Then second, we have the non-geometric modeling. Actually, non-geometric modeling we can apply for a phenomena or a physical process. In this unit we are going to concern with the geometric modeling. So we will study the different geometric modeling technique and how the geometric modeling is helpful for us in the representation of the object, and we are going to study some advantages and disadvantages also of these techniques and various methods of the geometric modeling that we are going to learn here in this unit. So let's see what is the geometric modeling, the introduction of the geometric modeling first, and then we will go into the details. It is the, what you can say simply, the graphic representation of the graphic image. So this graphic image will be generated on the computer screen with the three different commands on the computer. So what we can see the image on the computer screen. So this image will be generated with the help of these three different commands. So one by one we will see these three different commands which will generate the graphic image. The first type of command will generate the basic geometric entities like points, lines, circles. So these basic geometric entities can be generated with the help of these basic commands. Then we have the second type of command. So this will accomplish the transformation of these objects. So already we have seen the transformations of the object in the first unit, translation, scaling, mirror, shear. Even we have seen the undo transformation also, how we can do the undo transformation in the geometric transformation. So this undo transformation in the computer is nothing but the inverse transformation. So this is what a second type of command that will that is nothing but your transformation of these objects. Then third we have third type of command will cause the various geometric elements to be joined into the desired shape of the object. So whatever surface or whatever model we are making, so this model you have to join together to get the different shape of the object, and this can be possible with the help of this third type of command. So in many of the software we are using the extrude command to convert the 2D into the 3D object. Okay, so joining will be there. So different commands will be used in the third type of command, so that we can join the geometric elements together to get the different shape of the object. So this is what the three steps we are having in the geometric modeling. So first is a basic step, and this can be generated with the help of simple entities like line, point, circles that we are having. And secondly, we have the transformations that we are going to use. So various transformations can be applied as per our requirement of the object. And third, we have the commands which can have the various geometric elements that can be joined, so that we can get the desired shape of the object. This geometric model is stored in the database, and we can call this geometric model at any time for analysis, modification or the transfer. So any modifications you are doing or any transfer you are doing, these modifications or transfer will be done in the respective database, and it will be stored in the database. So consequently the changes will be made in the database, and then immediately in the geometric model that you can see on the computer screen. Even we can perform the analysis also. A lot of analysis softwares are available. So with the help of these analysis software, we can have the analysis. So we have the finite element analysis software, we have the various software as per our requirement that is available nowadays. So analysis of these models can be done. So we can see this analysis part, it is very fast, and we can get the immediate results also with the help of this analysis. So that is what the advantage of geometric modeling that we are having. Then geometric model, it can be used to evaluate the various properties of the object. Properties such as the mass, then the volume, moment of inertia. So these properties can be evaluated very easily from the geometric model that you have created using your software. So whatever model you have created, whatever is your shape and size of the model, based on that shape and size, you can easily calculate the mass, you can get the volume also, you can get the moment of inertia also. So this can be possible very immediately, very fast. You can get all these things calculated with the help of this geometric model. Now we can have this finite element analysis software. With the help of this, we can have the even advanced analysis of this geometric model. We can have the stress strain analysis, we can have the thermal analysis, we can calculate the displacement also. So this will give the idea for the designer how your model is behaving or how your design will behave, whether it will have the premature failure under the forces, whether it will work properly, or you require to go for the changes in the material, or you require to go in the material changes in the size and shape of the object. So immediate information will be available to the designer because of this analysis software. And whatever is the failure, sudden failure or premature failure of the component, so this can be avoided because of this analysis. The geometric model then can be used in the CAM software to generate a toolpath for the automatic manufacturing. Nowadays a lot of manufacturing is done by the machining centers. We have the horizontal machining center and the vertical machining centers. You can see that, so the toolpath of these CAM software or these CNC machines or VMC machines, so this toolpath can be generated directly from the geometric model. So you have to generate the geometric model, and from the geometric model you can automatically get the toolpath with the help of these softwares, and based on this toolpath we can generate the program for your manufacturing. So very easily based on the toolpath or based on the geometric model, we can see directly we can have the programming, and machine can understand after the program is ready how to manufacture the object. So this is a very best example how the geometric modeling can be used for the manufacturing also. So we have the Mastercam software. With the help of this Mastercam software, we can directly generate the toolpath, and this toolpath can be used in the CNC programming for manufacturing of the object. Then let's go for different methods of the geometric modeling. We have seen the importance of the geometric modeling and how the geometric modeling will be helpful for us in the manufacturing or in the design part. So geometric modeling can be used in the analysis, in the manufacturing also. So it is helping in the production process in a very contributing manner. So let's see now how these methods, what are the various methods of the geometric modeling that we are having. So we have the three methods of the geometric model that we will see. First method is our wireframe modeling. So as the name indicates, the model is constructed with the help of this wireframe. That's why the name is given as the wireframe modeling. Then second we have the surface modeling. So when we join the various surfaces, we will have the model. So this is what your surface modeling, depending on the shape of the object, depending on the type of the object, the surfaces may vary. So different surfaces when you join together, we will have the surface models. Then finally we will have the solid modeling. So solid modeling is again the advanced part of the surface modeling. So we are combining the volumes together of the different surfaces, and then we will generate the solid modeling. So out of these three modeling techniques, solid modeling technique is widely used nowadays as it offers the large advantage as compared to the wireframe modeling and surface modeling. So we will see one by one the wireframe modeling first, then the surface modeling, and then finally we will see the solid modeling technique. So let's see first the surface modeling, the wireframe modeling, then we will go for the surface, and then finally the solid modeling technique. So wireframe modeling, it is the oldest method of modeling, and it is very simple method for geometric modeling. Geometric modeling of an object is created by the very simple entities, that is the two-dimensional entities like points, lines, curves, polygons, circles. So these entities are used for generation of the geometric model. So we will see how the geometric entities can be used for the generation of the model. So simply you can go for the lines, curves, polygons like this for generation of these models. This model appear like a frame that is constructed out of the wire, and hence it is called as a wireframe model. So simply like a wire appearance will be there, and based on that, because of the wire appearance, it is called as a wireframe modeling. So we can see the different types of wireframe modeling we are having. So we have the three types of wireframe modeling. First is the 2D model. So this 2D model is suitable for the flat objects. So when you have the simple object, simple representation, only the two-dimensional representation, then we can go for this 2D modeling. So 2D modeling basically it is suitable for the flat objects. Then second one we have is the 2.5D model. Now it is what I can say, 2.5D model. It represents the three-dimensional object. It is just the representation of the three-dimensional object as long as it does not have side wall details. It does not have the side wall details. So this is a 2.5D model. So this will be simple representation of the object. If there is any side wall details, then this will be very difficult to represent with the help of this 2.5D model. So this we will see this one. Then we have the 3D representation. You can see now the 3D model. The 3D model are used for three-dimensional representation. You can see here clearly this three-dimensional representation of the object with the side wall details. So any details, side wall details, so you can see this can be easily represented in the 3D model. So these side wall details, the dotted lines, the hidden lines, all these can be very easily represented in the 3D model. So 3D model representation will be very easy, and 3D model representation will be very easy, and it will represent the hidden part of the object also, and this can be represented with the help of this 3D model. So it is the advanced form of the model, and this 3D modeling technique is widely used by many software nowadays. So it has various advantages over the 2D model and 2 and half D model. So wireframe modeling, let's see now the advantages and disadvantages of the wireframe modeling. It is simple to construct. We know that it is simply made from the lines, circles, curves. So it is very simple to construct with the help of all these entities. Then it requires the less computer memory for storage as compared to the surface and solid model. So as it is simply constructed with the help of all these entities, so computer memory and the storage required is very less as compared to your surface model and the solid models. Then the wireframe models, it will form the basis for your surface models. Okay, so whatever models you are generating with the help of this wireframe model, so from that you can extract, or you can go, it will be the basis for your surface model. Then we can say that with the help of this wireframe model, the CPU time required to retrieve, to edit, to update the wireframe model is less as compared to the surface and solid model. As you are having the less computer memory, less computer storage, so you can easily retrieve the data, you can easily update the wireframe model without much time. Okay, so time required will be less with for all these activities. So this is what your all these advantages for your wireframe modeling that we are having. Then let's see some limitations of this wireframe modeling. It is very difficult and time consuming to generate the wireframe model for some complicated objects. When we have the difficult objects, when you have the complicated shapes and all these things, then this method is not suitable, or it will have a lot of difficulties in representation of these complicated shapes or the complicated objects. Then some of the properties cannot be calculated with the help of this wireframe modeling, as it is not complete. It is constructed with the basic geometric entities. So we cannot calculate the mass, volume, moment of inertia. So these important properties is very difficult to calculate with the help of these wireframe entities. Then a wireframe model of the object is more ambiguous representation than its surface and solid model. So surface and solid model representation will be more clear, and it will have the less ambiguity as compared to your wireframe modeling. So some features, some parts may not be clear in the wireframe modeling. So that is the main disadvantage that we have in the wireframe modeling. Then let's see the second method of modeling, that is the surface modeling. So wireframe modeling, it is the basic modeling, so it is not used in the nowadays software for modeling because of various limitations of the wireframe modeling. The second method, that is the surface modeling, it is considered as an extension of wireframe modeling. So from the wireframe modeling or from these basic entities, we can generate the surface model. So this surface modeling, it is used for complex object like automotive bodies, aircraft bodies, ship bodies, castings, dies. So for representation of these complex bodies, complex shapes, we are using this surface modeling technique. Then it can be generated by using the wireframe entities. You can see the wireframe entities like curves, lines, it can be used for generating the surface model. Okay. So wireframe entity, you can see in the figure, the wireframe entity curve is shown here. Okay. So from this curve, we have the mesh, and from this we are generating the surface model. Then let's see now the advantages and disadvantages of this surface modeling. We can no doubt we can go for some complex object shapes like automotive bodies, castings, ship bodies. So all these can be very easily represented with the help of this surface modeling technique. Then we can have the less ambiguity as compared to your wireframe model. So three-dimensional objects or the complicated shapes cannot be represented, or it is very difficult to represent all this with the help of the wireframe model. So these disadvantages can be overcome in the surface model. With the surface model, it is possible to calculate the properties like mass, volume, moment of inertia. So these properties can be very easily calculated with the help of these surface model. This is not possible in the wireframe modeling. Now also we can go for shading of the object in the surface modeling. So we can have the different shadings for the surfaces in the surface modeling. So we can easily identify with the help of this surface technique, surface shading technique. So that identification will be easier. So that is also the one advantage of this surface modeling. Then the limitations. We have the surface model when the surface is very complex, and then no doubt we require more CPU time, the computer memory will require also more, and the storage will be more as compared to your wireframe modeling. So this is what in comparison of the wireframe modeling, no doubt your surface model will have the additional features, and because of this all this will see calculation time, the CPU time, the memory required will be more for your surface modeling. Then surface modeling is not suitable for complicated objects. So for when the object is very complicated, like 3D part and all these 3D parts with the details, then the representation of the object will be very difficult with the surface model, and we have only the one alternative, that is your solid modeling. Surface modeling is what you can say, it is up to some limit it will be accepted, but beyond that, when the object is very complicated, it is very difficult to represent the object with the help of this surface modeling. Now we have the third technique, that is a solid modeling technique. Now let's see how this solid modeling technique is helpful or it is advantageous over this wireframe modeling and the surface modeling that we have seen. Now it is the most easy and the most advanced method of geometric modeling. So lot of software nowadays we are using this solid modeling technique. So we have the Pro software we are using the CATIA software. So variety of softwares are available, and all these softwares you can see are using this solid modeling technique. Now what is the basic advantage of the solid modeling technique? We can have the easily we can convert the 3D model into the 2D model also. So that is the biggest advantage that we are having. But in the 2D model, if you use only the two-dimensional software, we cannot go into the 3D. But what in 3D modeling or the solid modeling, what is the advantage? We can easily get the two-dimensional shapes also from the 3D modeling. So that is the big advantage we are getting with the help of this solid modeling. So lot of softwares, lot of applications we are having with this 3D solid modeling technique. So lot of automotive application, advanced applications we are having with the help of this solid modeling technique. So that conversion process we can see very easily. We can convert the solid model into the wireframe model, or you can easily get the views also, front view, top view and side view. We can easily convert from the solid models. Now let's see some of the advantages and disadvantages of the solid modeling. It is the easiest and the most advanced method of geometric modeling, and nowadays we have all these softwares which are using this solid modeling technique. This will provide the better visualization. We can have the better comparison of your model, and better representation can be possible with the help of this solid modeling technique. With solid model, what you can say, it is easily very easy to calculate all these properties, mass, volume, moment of inertia, So you can easily calculate all these properties with the help of this solid modeling technique. Then it is not possible to some of the limitations we will see. We cannot calculate. It is not possible to create the solid model from the wireframe or surface models. Okay, so this wireframe or we can convert the solid model into the wireframe model, but the wireframe model or the surface model cannot be converted into the solid model. The solid model requires more CPU time, retrieve or edit or update the model, as the data or the memory required is more. So we will require to have the high grade computer or the upgraded computer is required for all these solid modeling technique. So friends, today we have seen the basic methods of modeling and what is the importance of geometric modeling. So we have seen the three basic methods of geometric modeling. So first method is your wireframe modeling, second is the surface modeling, and third is the solid modeling. So as per our requirement, we can go for the modeling methods. But out of these three methods, you see, the advanced software nowadays are using the solid modeling techniques. So as the solid modeling techniques offer the various advantages, it will have the less ambiguity in the representation, and the calculations or the analysis can be done very easily with the help of this solid modeling technique. Even the manufacturing also becomes very easy with these solid modeling techniques. So in the further part of the lecture, we will see the different types of wireframe entities that we are using for construction of the construction of the first model, that is the basic model that we are constructing with the help of this wireframe entities. So thank you.